So we have sixth lecture for moving charge and magnetism. In this lecture we will discuss motion of a charged particle in a magnetic field, especially in uniform magnetic field. So here I already drawn the figure. Magnetic field B is in inward direction. This cross shows it is in inward direction. And a charge of mass m and with charge q is dropped in uniform magnetic field. With velocity v as shown in figure. Okay. So charge experience force that we know. A force F is equal to Q V cross V. So that is we discussed in last lecture. Now we check the direction. So in last lecture also we discussed how to find the direction of the force. So use right hand palm rule, thumb place in y direction and fingers inward direction. Then perpendicular to the norm palm is in upper direction. So this is the direction of the force. અંદર તરફ હું V બતાવું છું. This is અંદરની તરફ. Sorry, અંદરની તરફ B છે. Okay. So this is the force. And if you see the magnitude, then it is MQVB. Because theta is equal to 90 degree. Because of this force, what will happen? We discuss in motion 11th that when force is acting perpendicular to the velocity, then direction change, not the magnitude. Every moment force will be perpendicular to V or perpendicular to the motion. So this is possible when motion of the charged particle is circular. So when you draw a normal to each point, it will passing through one common point, and that is the center of the circle. That is known. If your charge is here, then velocity in this direction. So again you plot the normal, so it will pass through this. If charge is here, again velocity in this direction, normal is passing through this. So this is the common point at which force is directed. So this is nothing but circular motion. The shape of the path will be circular. At each point, each point of the path, force is, this is magnetic force. Magnetic force is perpendicular to the path, or you can say velocity, instantaneous velocity. Okay. We also know that when a particle moves in a circular path, there is a pseudo centrifugal force. Is pseudo centrifugal force. Is mv square upon r. It is pseudo. Real ma mv. That is away from the center, and it is balanced by this force, magnetic force qvb. If these both are balanced, then this particle remains in this path. Sometimes it is also mentioned that this is centrifugal force required to keep in the circular motion. And to make this this inertia reference frame, we use pseudo concept. That is also one way. Okay, so QVB is acting toward the center realm, and it is, so this force is provided by QVB. You can say like that also. So what is my radius? So radius is equal to mv upon qb. So radius of the path is equal to mv upon qb. Here parallel component of force is 0. Means force is not acting in the direction of displacement. So work is 0. Work is possible when parallel component of the force is present, parallel to the displacement. Here it is not present, so work is 0. And which implies that delta K is 0. What is delta K? Change in kinetic energy according to work energy theorem. Which implies that kinetic energy is constant. Again, it implies that mass is constant, so velocity magnitude y is constant. So it moves with constant velocity. So whenever any charge dropped in uniform magnetic field with velocity v perpendicularly, magnitude velocity won't be changed and remains in a circular path with radius r. Work done is 0. If minus q charge is dropped, then what will happen? What will happen? So if it is negative charge, then I have to put the negative sign over here. So this is negative force. This magnitude, so not necessarily actually here, but it is negative. So now force is acting downward. And if magnetic field is available here also, then this charge, negative charge, will complete the rotation clockwise direction. This is anti-clockwise and this is the clockwise. So that is only difference. Positive charge moves clockwise, sorry, anti-clockwise, and negative charge moves in clockwise. If magnitude of charge same, mass is also same, velocity same, and of course magnetic field, then radius for both the particle will be same. Only direction of motion is different. Now, how much time it takes to complete one rotation? So we know that T is equal to circumference upon velocity. Okay. So 2 pi r upon v, you can find it from here, r upon v. I write here r upon v is equal to what? M upon qb. So that we put it here, 2 pi m upon qb. And you can also write the frequency of the rotation. Frequency mu is equal to qb upon 2 pi m. Frequency means how much rotation completed in 1 second, whatever the direction. And periodic time is how much time is taken to complete one rotation. So, if you see these two equations carefully, radius depends on velocity. But periodic time or frequency doesn't depend on velocity. What is the meaning of that? I put two charged particles, two identical particles are dropped in uniform magnetic field. With different velocity. Then radius of circular path will be different. But periodic time for both will be same. So here you can say that R1 is not equal to R2, but T1 is equal to T2. If R1 is not equal to R, which one greater than? So if V1 is greater than V2, then R1 is greater than R2. Or vice versa. If V2 is greater than V1, then R2 is greater than R1. Okay. Why it happens so? If we simply think, if we draw with more velocity, then you should complete the circle in less time. But it doesn't happen. Why? If velocity is more, then it moves in a circular path with larger radius, so it has to travel more distance. And if it is dropped with a small velocity, then small circle. Finally, when they come at this point, they are reaching at the same time. So periodic time is same, but radius are different. This both the equation, this equation as well as this equation, are very much useful in comparing the radius or periodic time or frequency for different types of particle. I take one example. Suppose I have proton, I have deuteron, and I have suppose alpha particle. I want to compare radius. I want to compare periodic time also. So what is my formula? So R is equal to mv upon qb. Okay. All have same velocity. I write same velocity. Okay. Now I do comparison. So is the mass different for all? Yes, mass different. Is charge different for all? Yes, charge different. So I can write radius is proportional to mass and inversely proportional to q. Okay. So for proton I can write proportional to mass of the proton upon charge of the proton. For proton. For deuteron, Rd is proportional to mass of the deuteron divided by charge of the deuteron. And for alpha particle, you know alpha particle, it is 2He4. Deuteron is 1H2. જો કદાચ ના ખબર હોય તો કહી દઉં છું. અને proton is 1H1. So here we have mass is 4. So again I write alpha particle proportional to mass of the alpha particle divided by charge of the alpha particle. Okay, now I can compare. Suppose I want to compare these two. So Rp upon R alpha, you can do like this: Mp upon Qp into Q alpha upon M alpha. Mass of the proton I write M, charge of the proton I write E, charge of the alpha particle is 2E because it has two protons, and mass of the alpha particle is 4m. This you should know this, then you can solve it. So it becomes half. Okay. So in this way you can compare the radius size. You can compare Rp and R alpha. You can compare Rd and R alpha. You can compare all three also by taking the ratio. So this is one method I have given how to compare the radius. Same thing you can do for the periodic time also. So do it for periodic time of the proton divided by periodic time of the deuteron. Also you find periodic time of the deuteron and periodic time of the alpha particle. That is for your homework. Okay. Still I want to discuss little bit more about this formula. Radius is given by extra radius is given by mv upon qb. So if you have given velocity of two particles equal, then use this formula. But sometimes they give kinetic energy. It is written in terms of kinetic energy or momentum. So this is nothing but P upon QB. Whatever the physical quantity given, you have to write formula of R in terms of that physical quantity. If momentum, then I write, if it kinetic energy, then I write 2 mk. Kinetic energy, relation between momentum and kinetic energy. P is equal to 2 mk upon qb. And sometimes particle is accelerated under certain potential difference. Then I write kinetic energy in terms of q into delta v upon qb. Of course, you can cancel root q. But whatever the physical quantities are given, you write R, formula of the R in terms of that physical quantity. If kinetic energy given, you write this equation. If potentials are given, you write in this term. If velocity given, you write this. So you can compare a radius of different particles. This is very important. Kinetic energy આપ્યું હોય તો મારે આ ફોર્મ્યુલા વાપરવાની. તમને કીધું kinetic n equal છે. તો અહીંયા જતો રહીશું. પોટેન્શિયલ સરખાથી એને એક્સેલરેટ કર્યા છે એવું કહેવામાં આવે, તો હું આ ફોર્મ્યુલાનો યુઝ કરીશ. બરાબર? એટલે જે તમને ફિઝિકલ ક્વોન્ટિટી આપેલી હોય એનો યુઝ કરવાનો થશે. તો તમે આ ટાઈપના ઘણા બધા ક્વેશ્ચન સોલ્વ કરી શકો. હવે એવું જરૂરી નથી સેમ કાઇનેટિક એનર્જી આપે કે એકની કાઇનેટિક એનર્જી K1 છે, બીજાની એનાથી ડબલ છે, તો વોટ ઇઝ ધ રેશિયો. તો ટૂંકમાં આ જ તમારે કોન્સેપ્ટ યુઝ કરવાનો છે. આ ફોર્મ્યુલા લેવાની છે અને ટેક ધ રેશિયો. જે કોન્સ્ટન્ટ હોય એને કેન્સલ કરી નાખવાના. બરાબર? કે ના વેરિયેબલ છે એનું રિલેશન તમને આપેલું હોય, યુ કેન મેક ધ રિલેશન બિટવીન ટુ રેડિયસ. અહીંયા સુધી આપણે ડિસ્કસ કર્યું કે વેલોસિટી વોઝ પરપેન્ડિક્યુલર ટુ બી. હવે ધારો કે v ઇઝ નોટ perpendicular to B, but we make certain angle. We make certain angle with B. Then what is the path? So here V is here, and this is the direction of magnetic field. This angle is theta. So in this case, what is the shape of the path? So here આગળ V has two components. This is component V parallel and this component is V perpendicular. So V has two components. V parallel and V perpendicular. This is V cos theta and this is V sin theta. If theta is equal to 0, then V perpendicular is 0. So particle will move in straight way right side without any deflection because force is 0. Again I repeat, if theta equal to 0, then particle will move toward right side. I am not talking about in the direction of B, but it remains in own direction without deviation. And if theta is equal to 90 degree, then particle will perform circular motion in a plane perpendicular to the page. In a plane perpendicular to the page. But it is not 0, it is not 90 degree, so what will happen? So this perpendicular component gives you circular motion. So because of this component, it tries to move in a circular path. And because of that, it moves straight. Here in right side. But both are present. So it moves in a helical path like this. This is helical path, helix. So radius of the helical path is determined by perpendicular component, that is mv sine theta upon qb. So this will determine the radius of the helix. Periodic time, that is 2 pi m upon qb. It doesn't depend on velocity. So radius now it is v. Who will decide the radius? V sine theta. And the distance between these two, it is called pitch. This is called pitch. So pitch means what? Starting from here, going here, completes one circle path, not exactly but helical, and coming here. So how much time it takes? So periodic time t. Into velocity in this direction. So velocity in this direction is v parallel. V parallel. So what is our t? So 2 pi m upon qb into v parallel is v cos theta. So we can determine pitch, and sometimes it is written like that, how much time it takes to cross this much area or length. So if you know the pitch, okay, and from pitch you can find how many rotations are required. So number of rotation you know the distance, and from that you can find it, how much time it takes. So like that also a problem can be asked. Still we want to discuss something, but in next lecture, and it is very important also. Because of this type of motion, we see very interesting phenomena in nature. Yes, so this is called aurora borealis. You can see in North Canada and Alaska. So actually what happens at the pole side, magnetic field intensity is very large. It is totally concentrated here, North Pole. And charged particles that is coming from the sun, sometimes these particles are trapped over here and they are moving in a circular path and then concentrate near to this North Pole. There are a large number of the charged particles which ionize the oxygen as well as nitrogen. And because of this ionization of the oxygen and nitrogen, we get some color. Oxygen gives green color while nitrogen gives you pink color. So this type of phenomena you can observe at the North Pole, and it is called aurora borealis. So this is natural phenomena, and it is believed that because of this charged particles are trapped and they are concentrated at the poles, and which ionize the oxygen and nitrogen. So we can see this type of najara. This is just for information. Okay, thank you very much.